Excuse me, Miss Johnson? Is there anything I can do? I really need to pass this class, but I'm just not getting the grade I need.
I gave you a lot of opportunities already. I just don't think you took advantage of them.
There's no extra credit?
You know, I really have to think about it. It's a hard thing to do. I don't want to just pass you in my class, but there is one thing. You can find the area and volume of my bunt.
To find the trigonometric function, we start with the general form of a sine. The amplitude is 7, which we found by measurement. The period equals 2 pi over b. The period is known as 27 from measurement. So b equals 2 pi divided by 27, b equals 0.23271. Then we must find the phase shift, which equals c divided by b, which equals 2.25. Then we use this to find c itself, which equals 0.52360. There's no vertical shift d because the cake is sitting on the ground. Then we plug in all these values to get the function. To find the area of the cross-sectional piece, we use the general form of integration. We evaluate from 2.25 to 11.25, which gives us the area of 45.121 centimeters squared. To find the volume, we use the shell method of integration in the general form, defined as 2 pi xy integrated from b to a. We plug in the specific equation found in part 1 into f of x. Then we evaluate this from 2.25 to 11.25. This gives us the volume of 1,635.524 centimeters cubed. Thanks for the lesson, Miss Johnson.
Anytime.
Who is it?
It's the plumber.
Plumber? I didn't call a plumber.
Did someone order a big chocolate bundt cake?
I did, but I don't have any money to pay for it.
Well, I'm sure there's some other way you can pay for it.
What do you mean?
Well, I mean, you can find the area and volume of the bundt cake.
Using the general equation of a quartic function, plug in the vertex values at h and k. Then plug in the known x-intercepts to find a. Once you have a, you can plug it in to find the function. To find the area of the cross-sectional piece, integrate the function evaluated from 2.25 to 11.25. The area comes out to 50.364 centimeters squared. To find the volume, use the shell method of integration evaluated from 2.25 to 11.25. The volume value is 1,897.8 centimeters cubed.
See you next time.
I'm still gonna need you to pay for that.
Hi, officer. Good afternoon.
Do you have any idea how fast you're traveling?
I mean, no.
You're traveling well over the speed limit, honey.
Are you sure?
I'm positive.
Well, is there anything I can do? I can't really afford another ticket. I've already had 2 tickets, and one more will get my license suspended.
Well, you could help me find the area and volume of this here bundt cake.
First we start with the general form of an ellipse. Then we plug in our known a based on the x-intercept at 11.25, 0. Then we plug in a point 2.25 and 7 to find b. Then once you've found b, you can plug a and b back into the general form of an ellipse. Then you manipulate that in order to get f of x. To find the area of the cross-sectional piece, you integrate the function from a to b. So plugging in our f of x, then we integrate from 2.25 to 11.25, which gives us an area of 47.159 centimeters squared. To find the volume, we again use the shell method, integrating from 2.25 to 11.25, which gives us a volume of 1,781.293 centimeters cubed.
So, about that ticket.
Yeah, you weren't even speeding. So hot out here.
Oh, Tony, why don't you come over here for a sweet treat?
Ooh, looks delicious.
But before you get this sweet treat,
You're gonna have to find the area and volume of my bunt.
I can do that. First, we use the general equation of a quadratic function and plug in h and k. Then we plug in the known x-intercepts to find a. Then, using a, we find the function. Then, to find the area of the cross-sectional piece, we integrate the found function, evaluated from 2.25 to 11.25, to find an area of 42 centimeters squared. Then, to find the volume, we're going to use the shell method of integration, evaluated from 2.25 to 11.25, to get a volume of 1,048.84.399 centimeters squared. Cubed.
So, how was it?
I don't know, I've never really liked chocolate.